Hello, everyone. I hope I'm audible as well as visible to everyone. Hello, and welcome to Unacademy. Welcome to another session of our NCERT series, where we are going to talk today about the case of humidity cloud formation and the intricate details associated with, for example, the type of clouds, the type of humidity, what is a fog, how does a fog get created, what is dew and dew point, the aspects of condensation is what we are going to cover today. Now, this is one of the final topics of climatology in the entirety of the fundamentals of physical geography, the NCERT book. Now, here basically before we start, an announcement for all of you that based upon based upon our coverage over this week of climatology, we are going to have a free session tomorrow at 6 p.m. on the app. You can scan the code, join the free session, and attempt the MCQs and the PYQs associated with all the topics that we have discussed today and also throughout the week. Ensure that you attend this session so that you are able to keep yourself up to track about whether you have understood it, or if you had thought that you have covered the topic earlier, indeed, is the concept clear or not. So do attend the session. Tomorrow, special class on the app, free for everyone, 6 p.m. to 7 p.m. in the evening. Okay. Now, basically, today the topic is going to be about the case of cloud, the fog formation, and so on. Now, before we proceed, again, the final announcement for everyone, the biggest offer for everyone, that is 16,999, where you get 12 months plus the free extension, is available to all of you. The offer ends tonight. Use the code IES English to avail the discount and ensure that you are a part of the preparation and you get guided by the best possible people in the industry. So, the topic that we are going to cover today in NCRT, it has not been covered in very great detail, as has been the case with the previous chapters as well. But nonetheless, we are going to go beyond wherever required. We are going to use the visuals and the animations wherever required and then get a deeper sense of understanding. Now, this is the topic associated with the case of humidity and precipitation. Now, what do we understand by the term humidity? Humidity is something that you hear about every day. Now, humidity, for example, the easiest possible reference point, when let's suppose you are in Chennai as compared to when you are in Bangalore. Now, you feel the climate to be much more pleasant in Bangalore as compared to Chennai. Even though, if you take a look at the world map, Bangalore and Chennai, they are not separated by huge degrees of latitude. They are very close to each other, isn't it? They are quite close to each other in terms of the latitudinal extent. But still, the temperature or the climate can be very oppressive in Chennai, pleasant in Bangalore. All of this has got to do with the case of humidity. So, what is this humidity? Humidity basically is the amount of water vapor or the amount of moisture that any air parcel has at any point of time. That is humidity. Okay. So, water vapor again is a gas, by the way. So, if you consider any volume of an air parcel, in that there will be gaseous molecules as well. Now, within those gaseous molecules, you will have the presence of water vapor. So the total amount of water vapor present in any parcel of air is referred to as humidity. Okay. Now, this humidity, is it going to be consistent throughout the planet? The answer is no. Humidity is different in different areas. Yesterday, we had discussed how the presence of moist air does bring about the tropical cyclones in the lower latitude. So, moisture level is quite different. But this more water vapor in the air is provided how? What process ensures that there is presence of water vapor in the atmosphere? It is the simple process of evaporation, right? Evaporation is the process which leads to the presence of water vapor. Now, this evaporation, if it is high, higher amount of moisture, greater humidity. If evaporation is less, the air is able to hold lesser amount of moisture. But the air parcel within itself, now it has its own capacity. Beyond that capacity, the air cannot hold any more amount of moisture, right? Just like, for example, if you consider yourself as a candidate. Now, when you consider yourself as a candidate, you will feel that when you study, you have a capacity. Beyond that, whatever you study, your mind won't be able to accommodate. So, that is your overall carrying capacity of your brain. Similarly, when we consider the case of air parcel, air parcel also has a limited carrying capacity. Beyond that, it is not able to hold any more amount of moisture in it. Okay. So that is the case of the carrying capacity of air. So what is carrying capacity? Carrying capacity is the maximum amount of water vapor that the air can hold at any given temperature. Maximum amount of water vapor that the air can hold. Okay. Now, let's suppose I consider an air parcel. Let's suppose it will have the gaseous molecules, nitrogen, oxygen, argon, carbon dioxide, it will have dust particles, etc. Isn't it? Now, it is in between these spaces that even water vapor will be embedded here, right? Let's suppose I heat this air parcel. I increase the temperature, right? Let's suppose I carry out heating. Now, when I heat it up, what will happen? The particles will gain energy. They will escape from one place to another. So now the air parcel that I have will have lesser number of gaseous molecules, will have lesser number of dust particles. That means within the same air parcel, now my ability to accommodate water vapor is much higher. So can I say that carrying capacity has increased upon heating? So heating of air parcel will always end up increasing the case of carrying capacity. Always. Right? It will increase the carrying capacity. So a warmer air is able to hold greater amount of moisture as compared to the normal condition. Conversely, however, if I cool this down, if I provide cooling, okay, in that particular case, if I consider the air parcel, now cooling means extraction of heat energy. We have talked about it in detail in the previous classes that cooling is associated with the extraction of heat energy. So when I cool the air parcel down, in that particular case, the particles will have lesser energy. They will slump together. They will come together. So that means the space available for the water vapor is now going to be much lesser. So what has happened? The carrying capacity has reduced, right? So that is basically where the carrying capacity of air is intricately linked with the temperature. Heating increases carrying capacity, increases carrying capacity. Okay. And cooling of air always decreases its overall carrying capacity. Okay. Right. So always the air parcel's overall ability to hold water vapor reduces when you start to cool it down. Okay. There will be a point when you cool it down that the air parcel is holding as much water vapor as is its carrying capacity. That is known as saturation of air. When the air is holding as much amount of water vapor as it can, that is known as saturated air. If you cool it down further, condensation starts to occur, right? So all the dew formation, frost formation, fog formation, cloud formation, mist formation, all of this is associated with the cooling of air beyond the point of saturation. Okay, only then the condensation can ever occur. So carrying capacity of air, as you can see, increases with temperature. As the temperature tends to increase, the air will hold more amount of moisture. So if I ask you, a warm air mass will have slightly lower temperature, hot air mass will be higher temperature. It is the degree of temperature. If I ask you, of the two places, that is 0 degree latitude and let's suppose 60 degree latitude, where will the carrying capacity be high? At 0 degree or at 60 degree? Pretty simple. 0 degree is where you will have a kind of a higher temperature, isn't it? Higher temperature. So that means greater carrying capacity. That means it is going to hold more amount of moisture of water vapor. Okay. So that is the association with humidity or between humidity and temperature. Now, furthermore, if you consider the types of humidity, that is basically how do you measure the humidity? Types of humidity is not that one humidity is different, another humidity is different. Humidity is the same amount of moisture. But when we say types here, it is about how do you measure difference of measurement. Okay, differences of measurement. So let's suppose, understand it first, then I will show it to you with the help of the images. Let's suppose I have an air parcel. Okay. Now it has got gaseous molecules. It has got the presence of water vapor also. I have to measure the amount of water vapor that will give me an idea about humidity. Now I can do it in certain ways. For example, I measure what is the weight of vapor, what is the weight of water vapor, right, per unit volume. I will fix the volume as 1 meter cube, that this is 1 meter cube of air. Whatever is the weight of water vapor, that is my measurement of humidity. That is one way. Another is, let's suppose rather than 1 meter cube, I fix a weight of air particles also. That amongst all the air particles, which will together weigh up to be around 1 kg, in 1 kg of gas, what is the amount of water vapor? That is also a measurement of humidity. Then another can be that, okay, this is my air parcel. Let's suppose its carrying capacity is 10 grams. Now, presently, as compared to its carrying capacity, what is the relative amount that it is holding? So, based upon any of these criteria, at any point of time, you can measure humidity in different ways. It is named differently. So, let us introduce ourselves to the different aspects of humidity measurement. One is the case of absolute humidity. Now, what is this absolute humidity? In this, basically, you take 1 meter cube of air parcel. Okay, 1 meter cube of air parcel. In that, whatever is the weight of vapor, that is your absolute humidity. So, for example, so absolute humidity is basically mass of water vapor per volume. So, let's suppose in 1 meter cube, I have 8 grams of vapor. So that means absolute humidity is going to be 8 gram per meter cube, isn't it? Now, based upon our discussion a few minutes ago, tell me something. Where will the humidity be higher, at 0 degree or at 70 degree north? Where will the humidity be higher? Always at 0 degree. Why? Carrying capacity is high. Also, you will find that there is the case of what? Higher temperature, so more evaporation. So absolute humidity decreases from equator to the poles, to poles, always. Okay. So then you have another measurement. That is the case of specific humidity. In absolute humidity, what did we do? We fixed the volume of air as 1 meter cube. In specific humidity, we fix the weight of the air. That in 1 kg of air, how much water vapor is present? What is the amount of water vapor per kg of air? So let's suppose in 1 kg of air, I have 5 grams. Okay. So specific humidity is going to be 5 gram per kg. Now, gram and kg, both of them are the units of the same scale. So that will come out to be 5 parts per thousand, because 1 kg is 1000 grams. Parts per thousand, also represented like this. This is the representation of parts per thousand. Okay. Now, it does not indicate much change with temperature. Why? Let's suppose I take a volume of air. In this, I have the number of gases, gaseous particles, which make up 1 kg. If I heat it up, particles will escape or expand, so the volume will increase. But still, 1 kg will represent the same number of particles. That is, let's suppose earlier 1 billion gaseous particles made up 1 kg. Even if I heat it up, still 1 billion gaseous particles will make up 1 kg. If I cool it down, still 1 billion gaseous particles will make up 1 kg. So the water vapor held between 1 billion gaseous particles, that is not going to change. So that is why specific humidity doesn't change, doesn't change with temperature. Remains consistent unless and until you have additional evaporation or condensation. It remains consistent. Okay. Then you have what is relative humidity. Relative to what is your maximum capacity. For example, your maximum capacity is to be able to study 5 hours. Let's assume, right? Now you have read only for 2 hours. So you have not read completely to your overall limit, right? So that is, you have read almost around 40%. So that is basically that you have utilized 40% of your energy. Similarly, when we say relative humidity, so what is the maximum carrying capacity that the air can have, as compared to that, what is the present vapor amount? So relative humidity comes out to be vapor present. Yes, Avantika. Divided by carrying capacity. So specific humidity can change under very rare circumstances, excessive heating or excessive evaporation. Under normal circumstances, at a place, at a time, it is consistent. Okay, it is not so variable as absolute humidity. Carrying capacity into 100. This is the case of relative humidity. So let's suppose I have an air parcel. Let's suppose I have an air parcel This is an air parcel at a temperature of 30 degrees Celsius. Now, carrying capacity here is 10 gram. Okay. Vapor present is 5 gram. What is the relative humidity in this case? Relative humidity in this case is going to be 5 by 10 into 100. That is how much? 50%, not 5%. Okay. That is basically going to be 50%. Let's suppose I heat this. I take the temperature to 40 degrees Celsius. What will happen to the carrying capacity if I heat it up? Carrying capacity will increase always, isn't it? So here, let's suppose the carrying capacity has increased to, let's assume, somewhere around 15 grams. Vapor present is still 5 grams. So what is the relative humidity in this case? 5 by 15 into 100, isn't it? How much does it come out to be? It comes out somewhere around 33.3%. Right? Let's suppose I cool it down. I bring the temperature to 20 degrees Celsius. What will happen to the carrying capacity? Will it increase or will it decrease? Carrying capacity decreases with temperature. So let's suppose the carrying capacity comes to be 5 grams. Vapor present is already 5 grams. So what happens to the relative humidity? It becomes 5 by 5 into 100. That basically means 100%. The air is carrying as much moisture as it can. Any further cooling will lead to condensation. Any further cooling. So, what does this tell us? That heating, whenever heating has happened, relative humidity has decreased. Whenever cooling has happened, relative humidity has increased. So, can I say relative humidity is inversely proportional to temperature? I can say so, that relative humidity is inversely proportional to temperature. I hope this is something which is understood by everyone. Yes? Now, why is this important? Now, I did put out a video regarding the wildfires in Europe, isn't it? I don't know how many of you have got the time to take a look at it. Do take a look at it. Why wildfires in Europe have become such a menace. Now, in the case of wildfires, so you see, whatever moisture is present in the air, if that amount of moisture keeps on increasing, air will reach saturation. It is on YouTube, yes. The air will hit saturation. If it cools down, then it will rain. Rainfall does not allow fire to occur. But then, if the heating continues, what happens to relative humidity? Relative humidity falls down, which means what? Chances of rain go down. That means greater solar insolation. That means more temperature. That means further fall down of relative humidity. So the dry conditions prevail, leading to heat waves. It is a kind of a cyclical process which can always lead to the occurrence of heat waves. This is something which is happening in the region of Europe, due to which the grasses, the vegetation, etc., everything is turning out to be very dry. Okay. Now, here One other factor is the case of basically your process of condensation. Condensation. Now, condensation occurs when? When does condensation occur? Condensation will always occur if air is cooled beyond saturation, right? That is when the water vapor which was present will be in excess, carrying capacity will reduce so much that excess water vapor will condense, right? Now, when air is cooled beyond saturation means, can I say air is cooled beyond relative humidity of 100? That is when condensation will occur, isn't it? Let's suppose you have the case where you bring out a water bottle from your refrigerator, keep it on your table. After a point of time, you will observe small, tiny droplets developing on your water bottle. Now, why does the bottle have these droplets? Is the case that water from inside the bottle is seeping out? No. It is simply because of the fact that when you think about the water bottle surface is so cold in the refrigerator, when you keep it out, when you bring the bottle out, let's suppose, okay, and when you keep it on the table, so the air in contact with the water bottle also becomes very cold. So this air parcel cools down, cools down, reaches saturation, okay, it reaches saturation, cools further, and that is where condensation occurs. And this condensation is observed in the form of tiny droplets that you have on the water bottle. So, greater the amount of moisture which is present in the air, faster will be the condensation. Condensation can occur at 20 degrees Celsius, also 30 degrees Celsius, also, depending upon what is the amount of moisture which is present in the air parcel. That is why, observe this. Now it is the rainy season. Your region, if it is receiving lot of rainfall, right, the day that your region has received a lot of rainfall, immediately after that, take a bottle out of refrigerator and keep it on the table. You will observe that the formation of droplets on the outside is very quick as compared to a very hot summer season. You will find droplet formation is less because humidity level is less. Okay, so that is basically where, if humidity is high, if humidity levels are high, that means condensation is faster, always. But condensation does not happen in thin air. Condensation always requires a surface. The bottle from your refrigerator has provided the droplets a surface. Similarly, in the air, when sometimes you see the fog, it is basically because the dust particles have provided that surface. Condensation will never occur without the occurrence of a surface. Okay? Now, then, sometimes, especially during winter or during rainy season, late at night or early in the morning, you observe that on the surface of your vehicles, you have the case of dew formation, isn't it? You have these tiny droplets of water which develop on the leaves, surface of your vehicles, metallic surface, etc. That is dew formation. Why does the dew formation happen? And what is this dew? So basically, when you have the vapor present in the atmosphere, okay, let's suppose you consider any surface. Now, during nights, what happens? The surface will end up losing heat, Through what? Through the process of terrestrial radiation, long wave terrestrial radiation, isn't it? So basically, the surface becomes cold, right? Now, the air which is in contact with the surface will have moisture, isn't it? This will cool down, cools, reaches saturation, reaches saturation. Once it reaches saturation, any cooling beyond this, right, that will lead to droplet formation. That is your dew. So, this temperature at which it reaches saturation, that is known as dew point. Okay, that is known as the case of dew point, right? So this is basically the formation of dew. Yes, Sudhanshu. In cloud seeding, you spray the particles up in the region of the troposphere and silver iodide, etc. And you basically allow for accelerated condensation to happen. That is the process. Okay. Now, I will ask you a simple question. If you have understood the case of dew, let me know the answer of this simple question. Okay. Let's suppose I give you two different places. One is the region of Delhi, other is the region of Chennai. Now, here, relative humidity is 70% because it is closer to the coastline. There will be greater amount of moisture. Here, relative humidity, Delhi is continental, drier. Relative humidity is, let's suppose, 25%. Temperature in both the regions is 33 degrees Celsius. Now, the question is, where does the dew form at a higher temperature? Or where does the dew form earlier, at the earliest? Chennai or Delhi? Do let me know. Saturation of air is when the air is holding as much amount of moisture. That is its capacity. That is its carrying capacity. If the air cannot hold any more amount of moisture, that is its saturation. Okay. Just like, for example, if you take a glass of water, you put 1 tablespoon of sugar, you mix it, sugar will be dissolved. You put in 2 tablespoons, mix it, it will be dissolved. But if you keep on putting it more and more amount of sugar, what will happen? It will not be dissolved, it will settle down. So why? Because water is saturated now. Any more sugar will not be dissolved. So that is the saturated condition. Similarly, air has a saturated condition. Beyond that, basically, it won't be able to hold any more amount of moisture. That is the saturation. Why there is dew formation in cricket pitch? Similarly, just like that, when the air reaches saturation, thereby further cooling. That is why dew formation you will always observe in the cricket matches is in the evening. It is not in the daytime when the sun is shining, then dew formation does not take place. Why? Because during late at night or during the evenings when the temperature reduces, that is when the air reaches the point of saturation and very quickly it will lead to the formation of dew. Now, Here you will observe, that is the reason why you will observe that even in cricket matches, you will observe that dew formation impacts which regions? Wankhede, Mumbai, right? Then Kochi, then Chennai, then Kolkata, Eden Gardens, Vishakhapatnam. These are the areas which are impacted by dew a lot. Not so much as Firozshah Kotla or a Dharmshala. Dharmshala to some extent during the winters, but not otherwise. Okay. So here, which region will experience faster or earlier dew formation at a higher temperature? Do let me know in the comment section. We will discuss it later. Now, if, however, the surface which gets in contact or the dew point is when the air reaches saturation, what if the air is so dry that the dew point is reached less than 0 degrees Celsius? Then what? Then you have the case of frost formation. Frost formation, you observe tiny ice particles on the grass, on the leaves, on the car windows, on the roof. That is the case of frost formation. So, when the temperature of the surface is so low, right, that basically moist air, moist air, when it gets in contact, it freezes. That is the case of a frost formation. So, if the saturation point is reached above 0 degrees Celsius and condensation happens above 0 degrees Celsius, dew formation. If condensation happens below 0 degrees Celsius, ice formation, what is also known as frost. So, frost is very common in the region of Himachal Pradesh, areas of Uttarakhand, certain areas of Punjab as well, Jammu Kashmir, Ladakh, right? Ladakh, not so much because air is very dry. Then upper reaches of Sikkim, parts of Arunachal Pradesh, there you will find the case of frost formation to happen. Here, condensation is happening below freezing point. Then you have the case of fog formation. In the case of fog formation, condensation does happen, but it doesn't happen on the ground. It happens in the air in contact with the ground, right? So when the air cools down suddenly and undergoes condensation, then you will find the tiny droplets of water, liquid water, attaching themselves to the dust particles. And that is what reduces the visibility, and that is what leads to the fog formation. So, for example, in the entirety of northern part of the country, during the winter months, you experience the fog formation. So, why will the fog formation happen? If, let's suppose, the air, it cools down, right, reaches saturation, and thereby undergoes condensation. Can fog be considered to be a cloud? The definition in many of the textbooks, you will find that fog is a cloud created at the ground level. Okay, that is basically what is the definition that you find here as well. So, technically, it can be considered to be like a cloud, but yes, the density is not equally as high as the clouds that you see up in the sky. Okay, now, so for the fog formation, what needs to occur? For a fog formation, typically the cooling down needs to happen. So that is where you basically need the ground surface to lose heat very quickly, very, very quickly. Okay. So clear sky. Because if there are clouds in the sky, they will block the loss of heat. That is why cloudy nights are generally considered to be warmer than the cleared sky nights. Why? Because when you have clear sky, that is when loss of heat is very high. So, clear sky, long winter nights, that is when the surface loses heat to such an extent that the air in contact can lead to the formation of fog. There are different types of fog which are present based upon how the formation has happened. It is not present in NCRT, so just brief coverage I will provide you. For example, let's suppose during winter nights, consider a region like Delhi. So, in winter nights, if you consider a region like Delhi, temperature will reduce to 1 degree Celsius, 2 degrees Celsius. As the temperature reduces, so the air in contact with that will cool down, the vapor will condense, it will form a thick layer of fog. But why has this fog been created? Because the surface has lost heat. How has the surface lost heat? With the help of terrestrial radiation, continued terrestrial radiation. That is why the surface has lost heat, isn't it? So, this kind of a fog formation is known as a radiation fog. This is experienced almost in the entirety of northern India. Now, you see, next day morning, when the sun starts to shine, the ground again heats up. So, when the ground heats up, the air immediately in contact with the ground will also start to heat up. What happens when you heat the air in terms of its carrying capacity? Its carrying capacity will suddenly increase. That means the saturated air will now be able to hold more moisture. So then the fog disappears. So that is why radiation fog, you will observe, starts disappearing from the ground slowly and steadily, whereas at a height, it is still foggy. But on the ground, it basically begins to dissipate. Early morning, you would have observed this, that at around 7 a.m., 8 a.m., fog vanishes from the ground, stays at a height, and then by the noon, it vanishes from the upper level as well. That is the case of radiation fog. Then you have the case of advection fog. Advection is basically the horizontal movement of air. So let's suppose whenever you have a cold surface, okay, in hilly areas like Meghalaya, Western Ghats, when the rainfall, so that is basically when the rainfall happens, temperature drops, moisture level is very high. Any further drop in temperature, if the relative humidity is close to 100%, will lead to condensation. Condensation will happen whenever relative humidity is closer to 100%. That is why you are able to see fog formation. Okay. Now, colder surface, if let's suppose you have a warm air, this warm air is blowing over the region of the colder surface. This warm air cools down, hits saturation, basically cools down further, leads to formation of a fog. Similarly, if you have winds which move upslope across the mountain, what will happen? It cools down, it loses temperature, and there also you have the formation of fog, upslope fog. Sometimes you will find that over the lakes, over the water bodies, right, reservoirs, etc., early in the morning, you will also find the formation of a kind of a fog, which gives you a steam like appearance. That is a steam fog. Why does it happen? So, early in the morning, during winters in particular, you have some evaporation which is happening. Some water is evaporating from the water bodies, very little amount, but some amount of evaporation is happening. You have cold winds coming from the land early in the morning or late at night, because land gets much colder as compared to the water bodies. Now, this cold wind which is coming from the land, or the cold air which is coming from the land, will immediately lead to condensation of the vapor. And that is where you have the case of the steam fog appears to be rising. So that is the case of the formation of a steam fog. Okay. So that is how you have various different types of fog formation which does occur. Okay. Now, similarly, you have the mist formation also. The difference between a mist and a fog is that in mist, the particle sizes are larger. Okay. And visibility is slightly reduced, not as reduced as a fog, but slightly reduced. Generally found closer to the water bodies. Wherever you have slight windy formation, there you will find mist formation. Then you have the case of clouds. Clouds also get created due to condensation itself. Now, why is it that you have the cloud formation? Very simple. Basically, if you consider the ground surface, now from here, if you have evaporation which happens, let's suppose evaporation occurs. Now, air will have vapor. This air parcel, it rises up. As it rises up, it cools down. It keeps on rising up. At one point of time, the air will reach saturation. Saturation. If let's suppose this air is still warmer than the surrounding, if let's suppose it will further rise up. As it further rises up, that is when it will basically form droplets around the dust particles. Tiny droplets across the dust particles. An accumulation of these droplets will lead to the formation of a cloud. So here, the simple process is due to heating, due to the process of heating, air rises up. As the air rises up, cools down, right? Reaches saturation, saturation, then undergoes condensation, and thereby leads to the formation of clouds. Okay, that is how cloud formation does take place. Okay, over a period of time, let's suppose you consider a cloud in any particular place. Let's suppose you consider the cloud in any particular case, any particular area. Now, in that area, when you consider, it can have water droplets also, it can have ice particles also, anything can be present. Water droplets can also be present, ice particles can also be present. When these particles become very heavy, that is when they start falling down. If let's suppose ice particles are there, when they become very heavy, they start falling down. They fall down and eventually they will basically be able to hit the surface in the form of rainfall. That is how rainfall does occur. This is the causation of rainfall. Okay. This is the basic aspect of the cloud formation, right? Now, this is where I want you to be able to revise up till this point. In the next session, we will be talking about the types of clouds, stratus, cumulus, cumulonimbus, etc. We will be talking about the types of rainfall and the world distribution of rainfall. That is something that we are going to be talking about in the next session. Today, we will restrict it only up till here. Tomorrow, in the special class, any doubt that you have, feel free to ask it. We will also be discussing slightly about the case of artificial rain. Yes, Vinita, dust particles, they act as a surface around which condensation can occur. Geography optional classes is being conducted by another faculty. I won't be taking the geography optional classes live this year. My geography optional classes are available in the recorded format. You can take a look at it. Any doubt, if you have, feel free to get in touch. So we meet again tomorrow. And on Monday, we continue with this, with the global distribution of rainfall and the case of thunder, lightning, and the cloud classification. Till then, do take care of yourself. Goodbye. Thank you.